5 times in Earth's history, life came within a breath of vanishing entirely. And the most terrifying part? It almost worked. Right now, beneath your feet, inside every layer of ancient rock, there is a record. A record written not in words, but in absences. Gaps where species simply stop appearing. Layers where the fossil record goes quiet, suddenly and completely, as if someone reached down and pressed a reset button on the entire planet. Scientists call these the Big Five mass extinctions, and today we are going to rank them, not just by the numbers, but by what they actually felt like to live through, by the sheer, unrelenting brutality of each event. But here is something most people get wrong about mass extinctions. They imagine a single moment, a flash, a disaster. The reality is far stranger, and in many ways far worse, because the most destructive forces in Earth's history were not always the fastest. Sometimes they were the slowest, and that changes everything about how we understand what nearly killed us. We begin at number 5, and we begin in the sea. Picture a shallow tropical ocean, warm, clear, teeming with life. Enormous reef systems stretching for hundreds of kilometers, more complex and diverse than almost anything alive today. Fish with armored heads, strange, jawless creatures drifting through the shallows. Coral so abundant it built entire landscapes. This was Earth roughly 375 million years ago, during the Late Devonian period. And then, over several million years, most of it died. The Late Devonian extinction did not arrive like a hammer. It arrived like a slow tide. Somewhere between 70 and 85% of all marine species disappeared, most of them concentrated in those warm, shallow reef environments. The reefs themselves, those vast, intricate ecosystems, essentially collapsed. What killed them is still debated. Volcanic activity shifting the climate, cooling pulses disrupting ocean chemistry, perhaps the rise of land plants, whose roots broke rock and flushed nutrients into the sea, triggering algal blooms that choked oxygen from the water. Possibly all of these at once. The reason this ranks 5th is not because it was gentle. It is because it was slow enough that some lineages had time to adapt, to migrate, to find refuge. The ocean lost most of its architects, but it kept enough builders to eventually reconstruct something new. Brutal? Absolutely. The end of the world? Not quite. Not yet. Number 4 takes us back even further, to a world before forests, before insects had wings, before anything with a backbone had fully committed to living on land. Approximately 443.8 million years ago, at the boundary of the Ordovician and Silurian periods, Earth executed what might be the most efficient extinction event on this list by a single metric: speed relative to damage. An estimated 85% of all Ordovician species were eliminated. That is nearly 9 out of every 10 species alive at the time. Gone. The mechanism was almost elegant in its cruelty. A rapid glaciation, a sudden, dramatic drop in global temperature, locked enormous volumes of water into ice sheets. Sea levels fell. The shallow coastal environments where most marine life lived were simply drained away. And then, just as life was beginning to adjust to the cold, the glaciers melted. Temperatures swung back. The ocean chemistry lurched in the opposite direction. Whatever had survived the freeze now faced the thaw. Think of it like this. Imagine draining a lake, waiting for the creatures that clung to the muddy bottom to adapt, and then flooding it back with water of a completely different chemistry. The organisms caught between those two states had almost no chance. Trilobites, brachiopods, the ancient architects of the Ordovician seafloor. Most of them did not make it through. It ranks 4th rather than higher because, despite the catastrophic percentage loss, the absolute diversity of life at this point in history was still largely confined to the ocean, and several major lineages pulled through. Life was wounded. It was not yet cornered. Number 3. And here the story moves on to land for the first time. Around 201 million years ago, at the end of the Triassic period, an estimated 80% of all known species vanished. Marine life was devastated. Ammonites, conodonts, entire lineages of ocean-going reptiles were wiped out or severely diminished. But what makes this extinction particularly striking is what it cleared away on land. The large Kurotarsi, the crocodile-line archosaurs that had been the dominant terrestrial predators, the animals that had kept early dinosaurs in check. Small, marginal, opportunistic. The likely culprit was one of the most violent volcanic episodes in Earth's history, the Central Atlantic Magmatic Province, a colossal outpouring of lava that flooded what is now the Atlantic Basin as the supercontinent Pangaea began to tear itself apart. Carbon dioxide poured into the atmosphere. Temperatures spiked. Oceans acidified. The sky itself may have been toxic in ways we can barely model today. And yet, here is the paradox that makes this extinction so fascinating. It was arguably the most consequential gift ever given to one group of animals. Because when the dust settled, when the volcanic winter finally lifted, the world that emerged belonged to the dinosaurs. Not because they were better, not because they were stronger, simply because they were still there. Every mass extinction is also an opening, and the Triassic-Jurassic boundary was the widest door in the history of vertebrate life. Number 2. We are now in the realm of events so severe they barely feel real. The Ordovician took 85%, the Late Devonian took 70 to 85%, the Triassic-Jurassic took 80%. But 443 million years before the present, and again 252 million years ago, something happened that makes all of those numbers look almost manageable. At the end of the Permian period, 96% of all marine species disappeared. Not 70, not 80, 96%. If you were standing at the edge of the Permian Ocean and watching, you would have seen the sea essentially die. The water warmed so dramatically, driven by catastrophic volcanic eruptions in what is now Siberia, releasing carbon dioxide and methane on a scale difficult to comprehend, that the oceans could no longer hold sufficient oxygen. Marine animals suffocated, not metaphorically, literally. The warmer the water, the less oxygen it holds, and when global temperatures climbed far enough, the chemistry of the ocean reached a point where breathing inside it became impossible for most complex life. On land, forest fires burned across entire continents. The soil eroded. The food chains collapsed from the bottom up. The plants died first, unable to photosynthesize in the chemical haze, then the herbivores that depended on them, then the predators that depended on the herbivores. This was not one catastrophe. It was a cascade, each stage making the next more devastating, an extinction event that lasted perhaps tens of thousands of years, a geological instant, but an eternity for the creatures living through it. The Permian Triassic extinction is called the Great Dying. It is the closest life has ever come to a full stop, and it ranks second only because of one extraordinary reason we will come to in a moment. Number 1. You already know the name of this one, but you may not know the full weight of it. 66 million years ago, a rock approximately 10 kilometers wide, roughly the size of a city, struck the shallow sea near what is now Mexico's Yucatan Peninsula. The energy released is almost beyond analogy. In the first minutes, the impact vaporized rock, sent tsunamis racing across entire ocean basins, and launched superheated debris into the upper atmosphere, where it rained back down as heat, igniting forests across the globe. In the weeks that followed, thick layers of ash and sulfur blocked sunlight. Temperatures plummeted. Photosynthesis stopped. Approximately 80% of all animal species on Earth were eliminated, including nearly every non-avian dinosaur that had dominated terrestrial ecosystems for 165 million years. Pterosaurs vanished. The great marine reptiles vanished. Ammonites, which had survived multiple previous extinction events, vanished. The world that had existed for the entire Mesozoic era simply ceased. And yet, and this is the paradox that brings us back to the very beginning, life did not disappear. In the darkness and the cold, small mammals huddled in burrows. Crocodilians buried themselves in mud. A lineage of small feathered theropods clung to existence in the ruined forests. They were the leftovers of a world that no longer existed. And from those leftovers, everything we know today eventually grew. The Cretaceous-Paleogene extinction, or KPG, ranks first not merely because of its speed or the percentage of species lost, but because of the scale of what it erased combined with the scale of what it accidentally created. It killed the age of giants. It opened the age of us. 5 events, 5 near endings. And across all of them, one pattern repeats itself with a quiet persistence that is almost impossible to ignore. Life does not survive mass extinctions because it is powerful. It survives because it is small enough, strange enough, flexible enough to find the crack in the rock and push through. The Great Dying took 96% of ocean life and left the world nearly silent. The Chicxulub impact darkened the sky and ended 165 million years of dinosaur dominance in what amounts to a single sentence of geological time. And yet here we are, reading the rocks, naming the absences, trying to understand what it means that this planet has been nearly erased 5 times and keeps writing itself back. Maybe the most unsettling thought is not that extinction happened. It is that it will happen again. Not because the universe is cruel, but because it is indifferent, and life, stubborn and improbable, keeps showing up anyway. The question worth sitting with is not which extinction was the worst. The question is, what does it mean that after every single one, something small and overlooked was already waiting in the wreckage to inherit the world?